This is part 2 of our Laws of Logarithms videos. Today we're going to be talking about condensing logarithmic expressions, meaning we are still going to use these same 3 laws that we had in the first video, but we're going to basically be going from the right side to the left side. So unlike last video, whenever we talked about taking the multiplication and splitting it up into addition and the division splitting it up into or expanding it into subtraction, what we're going to be doing today is taking multiple logarithms and trying to condense them into just a single logarithm. Meaning, if we see 2 logs that are being added together, we can condense them into a single log if we multiply the 2 things we were taking the logs of. Likewise, if we see subtraction between 2 logs, we can condense those 2 logs together if we divide the 2 things we were taking the logs of. And then for the third law, what we're going to be looking for is any coefficients in front of a log that we can move back to being an exponent. That's the 3 things we're looking to do today. Okay? If you watch the first part, you know that we always saved the exponents for last. That was always our last step when we were expanding. Since we're going in the opposite direction and condensing, we want to look for coefficients first to be able to turn into exponents. That wants to be our first step. For example, let's say that I gave you log, we'll just say log base 10, so it's just the common log and we can just leave it as log. So let's say I gave you 3 times the log of x plus 1/2 times the log of y plus 2. Let's say I gave you that expression and I simply asked you to condense those. What I'm saying is our first step is not to try and combine both of those logs together into one. Our first step would be to look at these coefficients and use that third law to take those coefficients and move them to the back of the problem, to the end of the problem, to become exponents. So like in this case, we'd move the 3 over to get a log of x to the third, and we would move the 1/2 to this entire expression to give us the log of the expression, the quantity y plus 2 to the 1/2, the entire quantity. Now that I've taken care of any coefficients, we can actually try and combine these into a single log. And so then we would want to use the first law where we are saying, okay, we have 2 logs being added together, so let's combine them into one and multiply the 2 things we were taking the log of. So applying that to this, we would have now a single log, but we would be taking that single log of x to the third times y plus 2 to the 1/2 power. Now that we've got this down to a single log, that would be a condensed expression. You don't need to do anything more than that. We don't actually need to take y plus 2 to the 1/2 power and try and, get it to where we could distribute the x to the third in or anything. That would be a condensed expression. Let's take a look at one more example here. Just like with the last one, first thing we're going to want to do is take care of any coefficients, any numbers in front of the logs. So we've got a 3 right here that we can move back to give us an exponent so that we would have the natural log of a to the third. Also have a 2 here that we can move to the front to give us a natural log of b squared plus 1 quantity squared. And we've got a 4 that we can move to the back here, and it is important for that one to notice that we are taking the natural log of both c and d, which means that 4 as an exponent is going to both of them. So you could choose to write that as the quantity of cd to the 4th, or you could actually show that 4 going to both of them and write it as c to the 4th, d to the 4th. Either one would technically be accurate. Now that we've taken care of all the coefficients, we want to combine all these natural logs together. we do want to take that in 2 steps because I only want to combine 2 logs at a time. So we'll just start working our way from left to right. So looking at just the first 2 natural logarithms here, these 2 right here, that's subtraction between those. And as we talked about at the beginning of this lesson, when we condense, that subtraction is going to convert into division, meaning we would have a single natural log, but we'd be taking the natural log of the quantity, or the rational expression, a to the third over b squared plus 1 quantity squared. And then that's still being added to the natural log of c to the fourth d to the fourth. And then we can do our last step of condensing these last 2 logs together. We know that addition condenses into multiplication. Recognize that if we are taking a fraction of the a to the third over b squared plus 1 quantity squared times c to the fourth d to the fourth, think of c to the fourth d to the fourth as the fraction making it over 1. That's how you want to think of this, meaning it's important you understand that when we multiply these together, it's the numerators of a to the third and c to the fourth d to the fourth multiplying together. And then really, we don't have 2 denominators to multiply because we're just taking the b squared plus 1 squared times 1, which is just going to be itself. So that gives us a final answer of a single natural log with a to the third, c to the fourth, and d to the fourth all in my numerator, and b squared plus 1 quantity squared in our denominator. That would be our final answer.